Hello everyone. Today let's solve the problem 19. So remove nth node from the end of the list. So what the question states here, we are given a linked list and an integer n. We have been given a linked list and an integer n. You can clearly see here. Our main task is to remove the nth node from the end of the linked list. From the end of the linked list they have given here, right? So we have to remove the nth node from the end of the linked list they have given here, and we have to return the modified linked list as the output. That's what they have given here. Here you can clearly see the list consists of 1, 2, 3, 4, 5, and when n equals to 2, we are removing the node from the end, right? N equals 2 they have given. This will be the first, and when n equals to 2, we have to remove the element 4, right? So while we remove the element 4, the list must contain 1, 2, 3 and 5 as elements. So that's what the output they have given here. Same goes with the second example. Here we are having only one element, so n they have given 1. When we remove the element 1 here from the list, we will get the empty array as output. So same goes with this one as well. When we remove, we have two elements here within the linked list, and n they have given 1. If we remove the first element, then only 1 is left in the output, right? So 1 is left in the array. We have to present this one in the form of output, right, within the array 1. So I hope the question is completely clear. Let's discuss the approach. How can we write the code, and then let's discuss the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, we'll be starting with the approach. Here, first thing we have to consider here as we are going with the 2 pointers technique. So first step is here we'll be making use of dummy node that is pointing to the head of the list. Will be making use of the dummy node that is pointing to the head of the list. This will be the first step. So why we are making use of the dummy node that points to the head of the list? Because it helps to handle the edge cases like removing the first node. Suppose we have 1 and 2 as element, and where n equals to 2 we have been given. So we have to remove this element and the output should be 2, right? In this case, dummy node will be very helpful. That is the reason we'll be making use of the dummy node that points to the head of the list, right? So this will be the first step. And the second step here is we'll be making use of the 2 pointers. Obviously, as I've said, one is fast and one is slow, and both starting from the dummy node. So both start from dummy node. This you have to keep in mind, right? So let's move on with the third step. Let's move the fast pointer. We will move this one n plus 1 steps forward, right? Just to maintain the gap of n nodes between fast and slow. Just keep in mind, we are moving the fast pointer n plus 1 steps forward to maintain the gap of n nodes between fast and slow. This is the third step, right? Let's move on with the fourth step. Nothing but we are moving the both pointers one step at a time until fast reaches the end of the list. We are moving both pointers at a time until fast reaches the end of the list. This is fine. I hope they have clearly mentioned here. We have to move the both pointers one step at a time until fast reaches at the end of the list. This will be the fourth step. The fifth step is at this point we know slow is right before the node that needs to be removed, right? Slow is right before the node that needs to be removed, right? At this point, slow is right before the node that needs to be removed, right? And we have to adjust the next pointer of slow to skip the nth node. Also, we have to keep in mind, we have to adjust the next pointer of the node, next pointer of slow to skip the nth node. So I hope this is clear. The final step is here. We will return the modified list starting from the dummies.next. We have to return the modified list. That's what the output they have clearly mentioned in the question. Basically, in the output we have to return the modified list, right? So we will return modified list from where? From dummies.next. This we have to keep in mind. From dummies.next here, we'll be returning the modified list. These are the 6 steps that we need to keep in mind. This is the approach that we will be basically going with. I hope this is clear. Next, let's discuss the edge cases one by one, and then finally hop into writing the code and finally discuss this one complexities of the code that we have written. Now let's discuss the edge cases one by one. First edge case that we are going with here is single node list. I'll just consider the input as 1 here, as we are dealing with the single node list, right? N also, let me give here 1. The output will be this one, empty array. Why? N they have given 1 here. We are considering n as 1 and we are removing this element. So the output will be empty array. List becomes empty after the removal, right? So this is for the condition single this one node list. So let's move on with the second edge case, nothing but removing the last node. So let me consider here input 1 2 3. You can consider anything, and let me consider here 1, and output will be here 1 comma 2. N is 1 and we have 3 elements. We are removing the last element, nothing but 3 here. We are removing this one 3, right? So the output will be 1 comma 2 here. This is for the condition removing the last node, right? Hope this is clear. Let's move on with the third or the final edge case here. Let's go with removing the first node. Let me consider the output 1 2 3 here. N has to be 3 and we are removing the first element, nothing but 1 here. The output will be here 2 comma 3, right? So here this is for the condition removing the first node, right? I hope these edge cases are clear, right? First one was for single node list, second one was for removing the last node, and the third one was for removing the first node, right? I hope all the edge cases are clear. Next, let's start writing the code here. As we had discussed in the approach, let's create a dummy node that points to the head of the list. Let me consider here dummy. This has to point to the head of the list, right? So let me give here new list node 0 comma head here. It has to point to the head. And the second step is let's initialize 2 pointers. We are going with the 2 pointers, right? Slow and fast, and at the dummy node. So let me consider here, let's slow equals dummy. Also fast has to be at dummy as well. That's what we had discussed. So we are just initializing the 2 pointers, slow and fast, the 2 at the dummy node. And let's move to the third part, nothing but let's move the fast pointer n plus 1 steps ahead. We have discussed this one as well. So we are moving the fast pointer n plus 1 steps ahead. So I'll just give here, I'll just consider while loop here. Decrement n while it is greater than or equal to 0. What we will do, fast equals n plus 1 steps ahead means next one, fast dot next here. I hope this is clear. So the fourth step is we have to move both slow and fast pointers until fast reaches the end, right? So I'll just consider here, we have to have the fast. So let me consider the fast as the parameter here. Slow equals slow dot next, and same goes with the fast here. Fast equals fast dot next here. So we are just moving slow 1 step forward, and also we are moving fast 1 step forward. I hope this is clear. The next step is let's adjust the next pointer of the slow skip the nth node. We have already discussed this one. We have to skip the nth node and discuss the next point. And adjust the next pointer here. How can we write how can we articulate this one in the form of code? Just give a slow.next equals slow.next. This is fine. Final step is we have to return the modified list as the output. That is starting from the dummy.next. So just right here, let's return dummy.next. This is fine. Let me format the code once and let me hit the run button. So here you can clearly see the sample test cases are getting passed. Let me hit the submit button now. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct. So let's quickly discuss the time complexity and the space complexity of the code that we have written, right? So here, what will be the time complexity here? Overall time complexity would be big O of size, right? I'll just give here SZ because we know that the algorithm involves traversing the linked list twice. We are traversing the linked list twice basically. Once to move the fast pointer ahead by n+1 steps here. This step here you can clearly see in the line number 6. Once to move the fast pointer ahead by n+1 steps. Nothing but fast we have initialized to fast.next. This one, right? And once to move both slow and fast pointers until fast reaches the end. This one, this condition what we have considered here. The algorithm involves traversing the linked list twice. Once to move the fast pointer ahead by n+1 steps and once to move both slow and fast pointers until fast reaches the end here. So total work is proportional to the size of the linked list. Nothing but here we have the total time complexity would be a big O of size or big of SZ we can give here. So what will be the space complexity here? Overall space complexity. The overall space complexity would be here big O of 1. So why here the space complexity is big O of 1, not the big O of n here? Because we are not involving any extra space apart from the pointers. You can clearly see. So slow and fast, right? We are not except some variables we have used, dummy, this one, apart from the pointers, we are not making use of any extra space, right? So that is the reason overall space complexity would be big of 1 here. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.